Hey, this is a video for 1.4, the carbon cycle. Check out the overview, set up your guided notes. The carbon cycle is the first of the biogeochemical cycles. Bio, living, geo, earth and rocks, chemical means molecules. So the complete carbon cycle involves many different steps. You do not have to know all of the details, but you should understand what is occurring during each process. First process is photosynthesis. Commit this to memory. You're taking atmospheric carbon dioxide, you're converting it into glucose. That occurs in plants. Respiration occurs in both plants and consumers, animals, also bacteria, decomposers. It is the synthesis of ATP from the energy that is stored in the bonds of organic molecules. In this case, you're taking glucose, converting it to carbon dioxide, and then releasing ATP. You need to have this formula memorized. Decomposition is a form of respiration. It's anaerobic respiration. But basically you're breaking down organic matter into simpler molecules. Oftentimes, in the absence of oxygen, you will release methane, CH4. Methane is organic, as is glucose, because they have both carbon and hydrogen. Gas exchange occurs between the carbon in the atmosphere and different components of the carbon cycle. You can have gas exchange between carbon dioxide and water. When carbon dioxide is added to water, you get carbonic acid. You will also have gas exchange that occurs between the atmosphere and plants, and you'll also have humans having gas exchange. Granted, they're taking oxygen in and giving out carbon dioxide, but they're still adding CO2 to the atmosphere. Assimilation is the uptake and conversion of carbon dioxide into organic carbon molecules. Basically, when you eat something that has carbon in it, for us anyway, for consumers, you're taking that carbon and making it part of your body tissue. Now, assimilation occurs in the ocean when marine invertebrates take carbon dioxide or the carbonic acid, or take the carbonate and make calcium carbonate skeletons. Assimilation occurs when plants take in carbon dioxide and make glucose and other molecules like starches and other complex carbohydrates like lignin. Now we have sedimentation. Sedimentation is when you have the accumulation of this organic or inorganic carbon compounds at the bottom of the ocean. Now, over time, it becomes an inorganic compound like calcium carbonate or limestone. And over time, you can also have fossilization that occurs in terrestrial areas. And fossilization is when you are converting these organic molecules. You're removing the organic molecules and replacing them with minerals. You do not have to know these formulas. However, you should know that fossilization is how we produce fossil fuels, which are coal, oil or petroleum, and natural gas. Now we have uplift, and uplift, we'll talk about this a lot more in future units, but it is the upward movement of these solid forms of carbon through tectonic activity. So tectonic activity occurs, and we're going to learn about that in Unit 4, but this calcium carbonate or this limestone can be brought closer to the Earth's surface. Now we have extraction, and extraction is not natural. It is anthropogenic, which means that it is caused by humans. It is the removal of these ancient carbon fossil fuels for use by humans. This wouldn't be a problem, except we want to burn that. So combustion is the burning of these carbon-rich compounds in the presence of oxygen in order to produce carbon dioxide. So combustion of fossil fuels adds carbon dioxide to the atmosphere. Combustion of like forest fires and volcanic activity also adds carbon dioxide to the atmosphere. However, all of this has been going on for 1 million years or for millions of years. This part over here is new. Now, we want to talk about carbon reservoirs and carbon sinks. A carbon reservoir is carbon that is readily available for movement between different forms. A carbon sink locks away that carbon for many years. And we really are concerned about carbon sinks because those carbon sinks are keeping the carbon dioxide out of the atmosphere. Carbon dioxide in the atmosphere is a bad thing because it is a greenhouse gas, which means it heats up and it transfers the heat to the molecules around it. So it re-radiates that heat into the atmosphere. So that is what is leading to global warming and climate change. Now, over time, carbon dioxide has increased, especially since the Industrial Revolution. This is a graph showing the last 60 years. And you notice there's little yearly fluctuations. That's because in the winter, there will be more carbon dioxide in the atmosphere because the plants aren't taking it in. And in the summer, there will be less carbon dioxide because the plants are taking the carbon dioxide into their tissues. So you see how it kind of fluctuates, but it is still increasing generally. Now you can calculate percent change. So between 1990 and 2000, what is the percent change? Remember, for a percent change, you need to use the final minus initial over initial times 100. So if we plug in our numbers, we have 370 minus 355 divided by 355. 15 over 355 times 100 is 4.2%. So what I would like you to do is respond to this check for understanding, complete practice problem set 1.4. I hope that this video was informative. I thank you for your attention, and I will see you soon.